back on the Titch. I'll show a couple of little show and tell items before I get into this week's machining project. But first of all, I got some copper 3/32 inch copper tubing from my favorite Ace Hardware. I think this is like $1.50 for 3 pieces of it, because this is the size they call for the oiler, versus 1/8 inch, which is a little bit larger, obviously, as you can see here. But I wanted to show this cool thing too. This little oiler, I wasn't sure if I was going to make my own lubricator or be able to buy one, but this small one here, this is the right size for the Titch, I believe, and I just got this off eBay. Of all things, a gentleman in Sweden was selling this, and it's a UK part, and I got it for a good price, so really excited about that. I appreciate it. The gentleman goes by something like Hags, is his nickname on eBay, so thank you, sir. And this also illustrates a point. Here is the cone for the connection. As you can see, there's a little sleeve there around the cone, and then the nut, of course, fits on the back side of that. But this shows you the difference between the ones I just made for the water pump and the conventional cone design. You can see that the conventional cone design has that long sleeve, so it's actually a little bit larger and a little bit larger piece of hardware that you end up using. So just thought I'd illustrate that. Shows you the difference between that and the plain cones that I recently made. The other thing is, you can see on the backdrop here, I pulled up my book to kind of refresh my knowledge on working on cylinder covers. I wanted to see the notes, any notes I had about when I did it, when I made them for the Allen Mogul, and compare them to how the directions or the instructions are for the Titch. Because here's the front and the rear cylinder covers here. I'll have to obviously cut the castings in half, and then the plainer looking ones are actually for the front, and this part is just a gripping piece, so you can grip it in a 3-jaw and turn it. It's not too much rocket science there. The ones with the little stand built into them or cast into them, these are for the rear, and the guide, the valve guide, will attach to these, to the extra part there. So I'll be working on those this week and bring you along for that process. Alright, before I cut the cover castings apart, I thought I'd do a quick segment showing, I already explained what they are, the front and the rear castings. Here's the cylinders. These are the steam chests that came with the set, and they'll be arranged like this. Show you that. Steam inlet will come in, actually it will come in here through this port, and that's the center slot there, and then the valves push or let the steam go to the front or the rear to give the locomotive the operation. One thing before I start any of the machining on those, I do need to file a recess to smooth out where these holes are. So I'm going to do that. There's the cylinder covers that I bought. They were not included in the original set. Here's some pistons and some additional slide valves, and some additional slide valve blanks, and these are the piston blanks. So they all have to be machined. And here's some 5/32 inch stainless steel rod that I can use for the valve rods and the piston rods. And here's a steam tee that I can use for connecting the two sides together. So there's a steam tee and a lubricator tee, and so this will be, I know this, funny thing is, this doesn't look like much, but this will be, who knows, a month or two of happy, fun machining time making all these parts, even though the cylinders are already machined, and it looks like they did a really nice job. So I'll bring along as we go. Okay, here we go with the cylinder covers have been cut with the bandsaw. I use my little Harbor Freight bandsaw over there, if you can see that. I use that for everything. And I cut them and then I use the belt sander to round them up a little bit, clean off a little bit of the flash, just to make it easier to turn them in the lathe. So here's the two front ones that I'll be attacking tonight, and the two rear ones, they cleaned up really nice. There's plenty of extra material ready to go, so off we go. And one more thing I wanted to show before I do the covers is I did use a file to file a little relief for the steam passages here, and I did that on purpose. Let me show you the file I used. I used an old triangular file that I've carefully rounded the end, because you don't want a file stabbing in and scoring up your inside of your cylinder. So I used this little file here with a rounded edge. It was about almost the perfect size for filing the little 3/32 inch 45-degree angle there for the steam passages, so the steam can go into the cylinders there. So that done, and also the file does distort the cylinders a little bit, so I used a pin vise with a 3/32 inch drill in it to just twist through and clear out the passages. Pretty handy to have. If you don't have one of these pin vices for holding a drill, you might want to get one. Okay, here's the second of the end caps, the little 1/16 of an inch register here, and then the outside diameter is turned to 1 1/8 inches. I will say the high-speed steel, I experimented around a little bit, and the round nose high-speed steel tool there worked great for removing the most metal. And then what I ended up doing to get the undercut, I used my, where to put it, cutoff tool. Here we go, the homemade smaller cutoff tool. I put it in an angle like this and just went in a couple thou just to give me the little undercut there. So I have a pretty good fit on the cylinders here. It's not perfect. It's a little, honestly, it's a little looser than I wanted, maybe a thou or so, but it'll be fine. So I'm very generally pleased with how that came out. Time to do phase 2 tomorrow. Last night I started making this special holder that will hold these end covers around this 1 1/8 inch diameter here that I'm tapping with my thumb. And it's just a piece of steel that I turned this part down to exactly 1 inch so that I could use it in a 5C collet chuck in the mill for holding these to drill the holes in them. This part I drilled, I turned down to 1.5 inches exactly, and then I drilled it out 3/4 of an inch. So the center of it is already drilled out larger than these registers are, so that once I part it off, which will be the next operation, then I can flip it around, grip it by this part, and then open that side up so that it's exactly 1 1/8 inches, and it makes a nice clamping action on the outside diameter of these end covers. Here's one of the front cylinder covers from my Allen Mogul, and I'm just showing this because there's a little design in it, and I'm going to do the same thing for the ones for the Titch. You can also notice the gap here. That's because of the space for the steam holes. And here's the collapsing vise, if you will, the collapsing jaw for the end caps. Now, this is one that I need to cut the end off and then face it and then put that little design in this. You can see how much smaller they are by comparison. I didn't shoot any footage of it, but obviously I used a boring tool to cut out the gap inside there, and then I took it out and I marked where it was, took it out, and sawed it so that it would collapse and pinch down and hold that. Alright, one complete. I just put a little, like a 20/1000 of an inch little dish in there to give it a little bit of a design. Just kind of eyeballed it. You know, although the first one of the rear covers, or the front covers, came out okay using this little device, actually I'm remaking it. The main reason is, if you see it, I was thinking that this little radius or fillet here between the 1 inch part and the 1.5 inch part would be fine for the 3-jaw chuck, because there is a little radius on the jaws. However, it was hard to get it clamped in there. When I would tighten it, would move a little bit, so there's a little bit of run out on the part, and I'm glad I got a chance to make it and test it with one of the rear covers, or the front covers, because they're a little less critical you know, as long as they seal, that's the main thing they need to do. So I'm remaking it, and this time instead of using an all the way rounded tool, I'm using a sharper point tool, and I've got a sharp edge there. So I think I'm going to have a lot flatter clamp against the 3-jaw. I'm also going to make the interior tolerances a little tighter than I made on this one. So we'll see how it goes. But the point is that if I'm going to use this method for machining the rear covers, remember the rear covers hold the packing gland and the piston rod and all that stuff, so you want to be really accurate there. The other big difference for the second one that I'm making, after I've formed the outside like I wanted, I checked and made sure the 1-inch diameter fit perfectly on one of my 5C collet chucks for future purposes. And also, I drilled out the center undersize. I didn't go ahead all the way to 3/4 of an inch. I did like 23/64 or something, just under the 700 thousandths diameter of my cylinders, and consequently the inner registers on these covers. What I'm going to do is part this thing off now at the correct dimension, and then I can flip it around and use my boring tool to bore out the center to the exact correct or very close to it, to the size for the register, and then secondly bore out the larger portion for the outer part of the register, the 1.25 inch, the outer diameter of the cover, I should say. Alright, here's the second one, and after I cut it off, I placed it in here. The fit is great. It's flush against the jaws of the 3-jaw, and I'm very glad I bored it out, or I drilled it out undersized, and I used my boring tool. Got a nice carbide one here, and bored it out just to the inner register size on these end caps, and then I bored it out larger and only 3/32 inch deep, and I got a nice shake-free fit here. It's super tight, and I can feel it's kind of making contact in both the inner and outer register. So I didn't get the outer surface finish. I should have made it a little thicker before I cut it off, but that's okay. It's just appearances. So I did smooth it with a file. So I'm going to mark it, and I'll take it out and cut it now with a hacksaw, and I should have a very nice. Okay, here's the second rear piece chucked up and ready to machine. Let me just show you. You can see you can see a little run out with this, but that's the uneven cast surface here. The stem, so to speak, is running very, very true. So I'm very happy with, even though it took an extra hour to make that second edition with the sharper edges. When you go to make yours, you can learn from my mistake and just make it that way. Okay, the second one came out really nice. I just finished machining it. I put the round nose tool back in. Let me pop this thing out and then show you both of them in the cylinders. Here's both the finished front ones in the cylinders. Got a nice fit with the register, and really, really happy that I went ahead and made the made the better fixture to hold these, because that'll be very important when I machine the rear ends. The rear valve covers, the rear piston covers are held the same way. They're machined basically the same way that, according to the book, you grab this part, the little stem and the 3-jaw, machine it flat, machine the register, machine the outer diameter, and then you flip it around and hold it in place like this, and cut the stub off, and then drill and tap this area for the piston rod and the gland. Okay, here we are. I've turned the register and thinned the outer edge to about 1/8 of an inch. There was a lot of material to remove to get it to this size, and I've got that outer diameter to 1.25 inches, or 1 1/8 inches, and it's a nice fit on my step chuck that I made yesterday, the second one. So getting ready to drill the number 21 drill, a 1/2 inch deep, and then this one will be done on this side anyway, and I can do the other one just like it, and then reverse them both in the step chuck. Okay, here we go with the second one almost done. I I did chamfer this a little bit. I used a little ordinary countersink. You got it smooth there. Looks a little dirty because of the cutting fluid, but important point is getting the fit right. I really played around with it and ended up having to use the cutoff tool again for the little undercut, and I came in straight in at this angle with my top slide to give it that undercut so it fits good there on the side. Another comment, it's nice to have the little step jaw. You can see, you can check your fit there, so it's nice for confirmation that you have a nice snug fit on your part. Alright, here we go with the right hand side rear thing. You can see how thin it is. There's 3/32 of an inch of material inside the step jaw, and I've carefully set this up. I tapped it with my little hammer, held it in place while I tightened the jaws, and then I went around, I tapped it and then went around and tightened all three of the places just to make sure it's nice and secure, and I've given it a good wiggle test because if it's going to come loose, you want it to come loose now before you start working on it. So the steps are saw this off with a hacksaw and then turn the dimension so that it's 3/8 of an inch total, about 0.282 I think. I did the math. There's not going to be much to clean up here, just clean up the face and then drill with the 9/32 inch. The book talks about a pin drill. Happily, I happen to have, it's an unusual size, but I actually have a 9/32 inch end mill. So I'm going to use that to make the tapping size hole for the 5/16 inch by 32 threads. And then we'll tap it and clean it up, file, deburr, and do the other one. That went pretty smooth. I used the same high-speed steel cutoff tool with a pretty pointy end and got it down to 282 sticking out. Now all we have to do is drill that center part out and tap it. So here I am using the end mill as a pin drill. 0, 100 thou, 150, going for 5/16, so clean it off. 0, 1, 2. I'll probably do this all at once. I just like to take it easy since it's a, the step jaw and everything. 0, 2, using my tailstock, it's got a pretty accurate indicator there. So now all we have to do is tap. The 5/16 32 is the thread I'm going to use. Alright, after using the pin drill / end mill to do the final tap hole, I used my 5/16 inch by 30 bottoming tap here. I have a complete set, all the different sizes, but I decided to just go ahead and use the bottoming tap since this is soft stuff. The goo you see on there is the tap paste stuff that I really like. So I've tapped it once by hand. I'll run it through one more time, make sure I get all the threads cut all the way to the bottom, but I'm not doing the machine tap, is what I wanted to point out. Basically, there's only a 1/16 or so of material between the bottom of the tap space and the wide open spaces going into the piston, so you don't want to deform that material. So I'm just tapping it enough, and I'm gonna, well, I've got it held like this, I'm gonna file and clean it all up, but that'll pretty much be it for this one, and I'll repeat for the other one. The only other thing to do, eventually we'll have to mark, make a center plug, and then mark and then drill and tap a 540 hole up here on the top of both of them. I'm thinking about doing that in the mill. I'll show you about that. One more thing. I had it in the chuck there. It was holding so nice, and you can see the part looks pretty good. You can see the threads in there. I put a chamfer in there. I ran the number 21 drill through. I ran the tap through one more time, and then what I thought while I had it nicely supported, I took my assortment of files. Let me grab them and hold them up here. I used all these files to clean it up a little bit more while it's being held like that. And the last thing I'm doing to it right now, hold your ears if you're on earphones, but using one of the coarse buffing wheels in my Dremel and going after it, just kind of getting any kind of grit crud and deburring a little bit, just getting them cleaned up a little. Pretty handy. Get that done. Okay, this came out pretty well. Here's the two finished rear, well, semi-finished rear blocks. And I made a little 5/16 inch 32 plug to go inside there, and there was a little center mark in there, so I'll be able to put this inside a collet block and in the mill, and then offset 5/16 of an inch and drill and tap a number 540 hole at the center of each of these gland boxes. And I'll show you what the inside looks like. You can see the 5/16 32 threaded portion, and there'll be some graphited yarn and then a packing nut that will go on top of that with a hole in it, of course, for the piston rod. So I'll bring you back. We'll work on the drilling and tapping the 540 pieces tonight. Right, closing in on the final stages of the rear covers. I've got this thing in my step chuck. I've got it in a 5C collet, a 1-inch collet, and my collet block in the mill, and I've carefully lined up the 0 point in the little turned plug, and I've made my 0, 0 on my DRO. So now all I have to do is offset that 7/16 and drill number 38 drill and tap the 540. Start with a little center drill. Go to a 1/4 inch depth. There we go. The number 38 drill. And tap by hand number 540. I've got my bottoming tap in here. This is one of the good taps I bought years ago from McMaster Carr. And it's looking good. One done, one to go. Hi folks, I'm still working on the LBSC TICH on the cylinders and the cylinder covers. As you can see here, I've gotten pretty far. I just stopped and added it up today. I was trying to do this all in one video, but I've actually got over 20 minutes of footage on just machining the covers themselves, not counting all the stuff about the bolt circle and drilling the holes. So what I think I'll do is I'm going to make this the intro for the first part, just talking about machining the cylinder covers, and I'll do another segment, publish it later on, probably this weekend or early next week, whenever I finish the bolt holes in the back cylinders and get all that done. So hope you enjoy. Please give me a thumbs up, make your comments if you like. I appreciate everybody and hope you have a great week.